Good afternoon, everyone, and welcome to the Blue Thread. For today's session, Mark Smith, your usual host, is unable to chair. He's on a business trip in Singapore and Hong Kong, and he's asked me, Martin McCrink, to guest chair for this webinar. I'm managing partner at Copper Consultancy, and we're a communications agency that specializes in infrastructure. At Copper, we combine insight, intelligence, and creative communications to deliver measurable impact for our clients. And for more than 25 years, we've helped pave the way for some of the most ambitious society-changing projects in the UK, supporting clients corporately to achieve their business objectives. We also carry out research to understand public attitudes to infrastructure, most recently, public attitudes to water, and I'll cover that later on. Today, we're discussing the topic of navigating the circular economy in the water sector, and I'm in the company of some great guests from WGM Engineering and Scottish Water, which I'm really looking forward to. Before I introduce our guest speakers, I would like to make a few observations about our subject. We all know that adapting circular economy principles is about getting rid of the old linear and exploitative model of extracting and using resources until they expire and then disposing of them for new resources. In the water sector, this take, make, dispose model has typically resulted in an abstract use discharge approach to water resources and the environment. At the moment, the vast majority of people who consume water supplied through public utilities have little or no understanding or interest in where that water has come from, or indeed where it goes when they pull the plug or flush the toilet. This has driven an approach of over-abstraction and exploitation of our water resources, with a focus on supply being matched to demand rather than demand being moderated by supply. In the UK, a lot of people do not know how much of this precious resource they consume, nor do they care less, but they do care if their habits are affected by the lack of supply brought about by drought conditions. Our industry has been built to guarantee endless quantities of food-grade water at very low financial cost to the consumer. But what about other costs to the environment, to future generations, to people in parts of the world that will simply be unable to live in places that were previously abundant with water? In the UK today, the average per capita consumption is approximately 145 litres per person per day, and that has not reduced over recent years. So, as climate change takes hold, and with an increasing population in the UK, we are looking at building new reservoirs, desalination plants to fill reservoirs, and measuring resilience as being able to continue to consume what we want, no matter what Mother Nature throws at us. And this doesn't sound right. Where is the focus on water recycling schemes, rainwater harvesting, water reuse, as well as reducing our per capita consumption to 100 litres per day, as WaterWise recommend? The investment in these technologies and approaches are minimal compared to what will be spent on pouring concrete and pumps over the next few years. Indeed, a circular economy approach is absolutely needed if we are to succeed with a net zero agenda and develop and build a sustainable water industry into the future. So a bit of housekeeping before I introduce our speakers. Firstly, you'll notice that all attendees' microphones are automatically muted throughout the webinar. During the presentations, you can post questions, and there'll also be a Q&A session at the end of the presentation. So if you put them in there, we'll be able to see them. We'll get through as many questions as we can, and we'll make sure that if questions can't be answered due to time constraints, that they will be answered after the webinar. And shortly after the webinar, you'll receive a short survey as well. So please do fill that in, and that will help us improve our work for future webinars. So I'd like to introduce our three speakers. Firstly, Tamsin Kennedy, Circular Economy Lead at Scottish Water. Tamsin has gained over 20 years of water industry experience in innovation and construction roles. She has a Master's in Water Resources, is a Chartered Environmentalist and a Sustainability Excellence Associate, and currently leads on Circular Economy in Scottish Water. Secondly, Dr. Grant Hempel, Circular Economy Project Manager, Research and Innovation at Scottish Water. Dr. Grant Hempel is a Project Manager in the Research and Innovation team at Scottish Water. In his current role, he has worked with with Scottish Water to develop the circular economy approach and lead circular economy initiatives and projects. And lastly, Jason Cram, Technology and Innovation Director at WGM Engineering. Jason is a Technology and Innovation Director at WGM, a specialist provider of sustainable approaches in engineering services. He has 25 years experience in the design and delivery of major water and wastewater projects across the UK and Ireland. In recent times, Jason's focus has been on the delivery of innovative and sustainable solutions that embrace circular economy principles and provide significant carbon benefits through offsite engineering, modular build technologies, and design for manufacture and assembly approach. So first off, I'd like to hand you over to Tamsin and Grant, who are going to talk to you about Scottish Water.
Hi everyone. I'm hoping you can hear me fine. I can't see anyone to get a response, but we'll go for it. I'm Tamsin Kennedy, and with my colleague Grant, we're going to talk to you about what the circular economy means to Scottish Water. Next slide, please. And again, thanks. Today we will cover how the circular economy fits into our strategy, our circular economy approach, describe some of our projects, and then discuss how the circular economy relates to climate adaptation in the water industry. Next slide, please. Thanks. As this webinar is international, you may never have heard of Scottish Water, so I'd like to take you through some numbers. We are a publicly owned utility and the sole provider of water and wastewater services to Scotland. We service 2.62 million households and have 1,838 wastewater treatment works. These can vary in size from a few houses all the way up to a large city of 1 million people in Glasgow. Also, we have over 33,000 miles of sewer pipes, which is about 1.5 times around the Earth. So you can agree, it is not a small job to deliver here in Scotland. On the right side of the slide, you can see our ambitions and our 10 strategic objectives. As you can see, embracing the circular economy is one of our priorities. Next slide, please. To follow through on that strategic objective, Grant and I developed Scottish Water's approach to the circular economy. This is made up of 4 objectives that are based on the principles from the Ellen MacArthur Foundation. Embedding circular economy behaviours involves reviewing our training, processes, and decision-making to include it at all levels. It also enables us to design the circular economy systems of the future and work with our customers and suppliers to achieve them, like WGM today. In working with nature, we minimise our demands on the environment and increase biodiversity, as well as incorporating more biological elements into our treatment processes. This also includes a blue-green infrastructure. Keeping assets performing is not just about extending the working life of our assets. It includes how to design them in a modular fashion so they can be repaired and repurposed easily. And it also looks at the materials we use in them. Finally, viewing waste as an opportunity is about recovering valuable resources from our water and wastewater treatment. This objective also includes removing pollution and preventing any material going to landfill, where it has a knock-on detrimental effect to costs and carbon emissions. So these is our circular economy approach objectives, and they're written in a way to make them accessible, easy, and actionable for our employees, and something that can always be in the back of your mind. Now I'll hand over to Grant to take us through some of our circular economy projects where you can see these objectives in action.
Thank you, Tamsin. Hi everyone, thank you for joining this afternoon. Next slide, please. So what I'd like to do is just try to bring to life those 4 objectives that Tamsin spoke about there with 3 examples. So if we firstly look at the blue one around kind of circular assets and focusing on pump refurbishment, This is definitely fits with our kind of keeping assets performing objective that we set. So this current project actually came from discussions with WGM Engineering when we were working on a different project that was looking at surplus assets that Scottish Water have. And from this, we identified that around 5% of all our assets were classified as surplus, so no longer in use, and that about 15% of these surplus assets were pumps. And it always makes me think of the Zero Waste Scotland quote that's I quite like. So around 4/5 of Scotland's carbon footprint comes from products and services we manufacture, use, and throw away. So if you're putting your kind of circular economy thinking hat on, it seems like potentially a bit of a waste not to kind of do something with these. Surely there's an opportunity to do something prior to assets being classified as surplus. So with this in mind, we identified pumps due to their size, their usage, and really the availability, thought they'd be worthwhile examining. Effectively, what we wanted to trial was a service model to refurbishment. So we would refurbish a pump, hold it in stock, and when a pump is needed somewhere else, we would be able to send that refurbished pump out to the site. So it could go from one site and move around to different sites. But before we could do this, we thought that we had to kind of understand exactly what was happening with pumps and kind of create the case for it. So in collaboration with WGM Engineering, for the last 6 months, we've been collecting data on refurbished pumps in the west region of Scotland, so Glasgow and kind of surrounding areas. At present, we're analysing this data and we're looking at the kind of carbon savings of refurbishment repair. We're looking at the cost of refurbishment over buying new, and we're also looking at kind of the common operational issues and various other things to kind of get a full view of what's going on. Jason will talk, I think, a little bit more about WGM's approach to refurbishment later on, but I just think this is a good example of us trying to stop or think about, do we need to automatically buy new? Can we kind of improve what we have or do something with it? So the second example that I would just like to pick out is around training, so in the pink in the middle there. So Tamsin highlighted one of our objectives is around embedding circularity into our processes, skills and decision making. So working with Zero Waste Scotland support service, we identified that a good starting point would be creating a bespoke training module, and this could maybe act as a building block to help us with this. So working with the Zero Waste Scotland team, we thought this was really crucial to the success of it. They had extensive knowledge on circularity, and it would also help us internally establish the credibility of the training course. Basically, it wasn't just Tamsin and I telling people what to do. We had an authority behind it as well. So we produced an interactive online training course. So it talks about the circular economy in terms of introducing it, highlights the Scottish context, which is obviously important, and brings up our proposed circular economy bill that's under review just now, and tries to give some relatable examples from a broader Scottish perspective. In the second half, what we were then able to do is bring in our Scottish Water circular economy perspective, so these objectives that we've got, and really link it to the roles and behaviours that we were looking for from every type of employee that we kind of have. So what we're looking to do is really build a baseline common understanding with our employees and try to create a shared purpose. Of course, a training module alone won't do this, but we've got to start somewhere. By designing it in two parts, the generic beginning and our special Scottish Water focused second part, it allows Zero Waste Scotland and then other organisations to potentially take the first part and then build the second part based on the needs of their organisation. So I guess something that we thought would be usable by Scotland. Last time I checked our numbers around this, we'd achieved about an 84% completion rate in our procurement and supply chain team, which we're quite happy with because we identified them as an area or people that play a really important role in the success of enabling circularity in Scottish Water. So we can give ourselves a little kind of pat in the back so far for that. We've got 3,000 odd people more to go now. And the last example really is around resource recovery. And why I really like this example is it actually touches on all four of those key objectives that Tamsin spoke about in a way. So we're currently designing a resource recovery demonstrator for Alloa wastewater treatment work, which is in kind of central lowlands of Scotland, for those that aren't totally familiar. With resource recovery, what we're trying to change is a bit of a mindset on what we consider as waste. We want to think of waste as an input material that can create valuable products as new outputs. Okay, so trying to reframe it slightly. So this is an ambitious demonstrator that basically takes an existing asset and tries to improve it from a circular perspective instead of building something brand new. So again, we're trying to live that keeping assets performing mind frame. So we've been working with Atkins Realis for the last kind of year and a bit, and we've identified 4 technologies that we think can recover. Next slide, please. Okay, so what I would like to do is just show you, this is the image of our wastewater treatment works from bird's eye view. And I'm not going to talk through the wastewater treatment process, just highlight the 4 technologies that we've selected at this stage. Fantastic resource on the wastewater process if you want to go look at it on the Scottish Water website and learn a little bit about it. So firstly, in green, it's just near the kind of top of your screen, is our grit recovery. So grit enters the wastewater treatment works from road runoff and construction sites. And what we currently do with grit is send it to landfill, or had currently done with grit is send it to landfill. We collect the grit during the filtration process of wastewater treatment work. But what we've kind of learned is that this is a waste stream that we can turn into something valuable as well as reduce emissions. So again, it's a fantastic example of finding use and value from something that we traditionally thought of as waste. So the grit can be used in the recycled aggregate in construction, which obviously kind of helps in terms of quarrying for raw materials and really helps us kind of do good things with the life of materials. So secondly, in blue, if you look at the site, is cellulose recovery. I'd read a statistic around Europe, and I was trying to extrapolate that to Scotland. So it said that in a particular European country, each person uses approximately 1 roll of toilet paper per week. So I was trying to think of it from a Scottish perspective. For us, that would be something like 5.5 million rolls of toilet paper per week, something like 286 million rolls of toilet paper per year. So seems like it's a product that's not going anywhere. So we have to deal with it in the process. What can we do with it? So toilet paper itself is about 1/3 of the burden on the treatment plants. And if we reuse it as cellulose, this helps the burden go on. So what we've kind of identified is that recovered cellulose as a material can be used in kind of various formats, so crops and construction. So again, it seems like a good use for something. Again, if we're removing cellulose earlier on in treatment, it actually helps kind of reduce the sludge production and energy consumption of the plant down the line. So another positive thing to consider. Okay, so thirdly, hydrothermal liquefaction, and I'm always happy if I say that correctly. So we'll now refer to it as HTL from here on in, just to cover myself. So that's the red image that you can see on the site there. So the HTL process converts wet organic waste into renewable fuels and other valuable byproducts. So the output of the system effectively is kind of a biocrude oil or natural gas, or both, depending on your system configuration. So the fuels produced release no net new carbon dioxide, since the feedback comes from renewable biomass and wet waste. So again, a really nice thing to have. And lastly, if you look at the yellow, so this is algae. So this is effectively includes polishing off the final effluent by microalgae to repair nitrogen and phosphorus, and potentially store carbon capture as well. So the nutrients recovered by the microalgae-based process can also be used as fertilizers. So what we've seen in terms of kind of agricultural, this is worldwide one of the most important things, or kind of soluble forms that it's used for. So again, like another good outlet for it. So if I was thinking about the resource recovery demonstrator and the broader things, there's 4 really good things that you can pick out from it. There's lots of viewing waste as an opportunity, so definitely trying to think differently. We have the working with nature bit because there's a lot of potential around enhancing the biodiversity of Alloa. We're definitely keeping assets performing. We're looking at this existing site and improving it. And we're also really thinking about the behaviour change that would be required to view a site in a different way, and also what our operators would be expected to do. Next slide, please. Tamsin.
Thanks, Grant. And we're very excited about our resource recovery project.
Yes.
So climate change and the circular economy. These two concepts might not be ones that go immediately together in your mind, but I'm going to explain how they can help each other. So if we think about what is increasing first, rainfall, something which here in Glasgow, I know a lot about. Okay, so one of the ideas of the circular economy is about keeping things local. So this removes transport costs and carbon and reduces potential losses. If we treat surface water at source, we reduce the size of the pipes needed to move all the water and reduce the amount of chemicals required to treat that volume. It is much easier to deal with a small increase in rainfall on a small patch than all those small increases added together. Emission targets are also going up, or rather they're getting tougher to meet. We all know about net zero, but soon we will need to go beyond net zero, and this is where the circular economy comes in. By using renewable energy, recycled materials, and low maintenance options, we reduce the emissions across all three scopes. Another thing on the rise is population numbers. An answer to the increase in treatment requirements is the circular idea of modular design. Not only can you repair your assets more easily and increase their performing years, you can also add additional capacity. Of course, there are also things decreasing due to climate change. For laughs, rainfall is also going down and has the same mitigation as increasing. Go local with your network. Source treatment means you don't need the vast quantities of water as a carrier of sewage long distances. Every day we hear of more species at risk by our changing environment. If we include more nature in our projects, such as the blue-green infrastructure, and for example, hedges instead of the fences, we can provide habitats for flora and fauna. Finally, we all know budgets are decreasing and money is tight as it is being used for other things. By creating common specifications across our industry, we can reduce bespoke work and allow reuse of assets. By taking materials from one project to the next, it will also save us money. And I'm pretty sure you will hear about this from Jason as well. So I'm going to hand back to Grant for our last section.
Okay, next slide, please. Okay, so quite a lot of content on this slide. So what I would maybe pick out a few things to just summarise. Tamsin made a lot of comment there basically about design. It's really hard to be reactive all the time. So I guess we really need to think about being proactive in terms of designing for circularity earlier on through modular design, standardization, kind of thinking about assets from cradle to cradle effectively. Maybe the one thing I'll draw out from our examples so far is that there's been a lot of collaboration to be as successful as what we have. So Scottish Water, Tamsin and I cannot embrace the circular economy by ourselves. We need collaboration, we need more collaboration, we need to challenge each other's linear thinking, I think is where I would put the opportunity. Thanks, next slide.
Great, thank you both for that presentation. It's really interesting. It's interesting to see the combination of the principles and the real life example there as well. Just a couple of questions for you both, if that's okay. You talked about the principles and the examples of how we can change things. For you, what things are you most excited about in terms of the outcome and the opportunity of the principles that you've talked about?
Thanks, Martin. I'll take that one. So for me, I'm most excited about embedding the circular economy behaviours. I mean, nature, waste, assets, they are all good, but they're mostly technology and innovation based. To truly move the dial on the circular economy, we need to think differently about what we're doing. Like consider reuse at the start of the project, not at decommissioning where it normally happens, and factor the environment and next generations into our cost benefit analysis. So at Scottish Water, Grant covered the training, and that's really changing our organisation. Now, a good proportion understand why we are embracing the circular economy and how they can contribute. So it makes those conversations and decision making easier. The other part that's come out from behaviours is about our resource recovery strategy, which is living through the resource recovery factory demonstrator. So it used to be the bioresources strategy, but now it's evolved and looking at all the potential resources we can get at every stage of our treatment and construction to support the Scottish economy. So I believe this is going to fundamentally change what our assets look like in the future. And, you know, in 50 years' time, Scottish Water might look completely different, but in a really positive way.
Right, sounds good. Grant, well done with the not the acronym that you spelled out. That was I'm not going to try it myself. That was good. What do you think is the big? What you've set out is really positive. Clearly, this should be commonplace. What do you think the biggest barrier is, and why isn't it normalised? Why isn't it universal?
Yeah, so in terms of, I guess, thinking through our challenges, there's probably maybe 2 or 3 things that I would pick out. Probably it's around that if we're truly embracing circular economy, it is transformational. We're completely shifting our economic model. So from a Scottish Water perspective, as a publicly funded utility firm, we are focused on water and wastewater services. So how much does something like a resource recovery demonstrator shift us a little bit from that? What's involved in doing that? As part of that, where does the kind of the market making element come into it? We are recognizing things that we thought of as waste and had little value. We're now thinking actually they have a lot of value, but how do we exchange those? How do we determine value? What part of business do we kind of play? And lastly, very briefly, data. It is the data around circular economy, figuring out what to collect, who to collect it, where to collect it from. Is it Scottish Water data? Is it WGM data? Trying to connect everything, and then also that is really difficult to go. We've got a project that we're about to start as our partner ecosystem team who are looking at scraper bridges, bridge scrapers with Zero Waste Scotland, University of Edinburgh, and Topolytics. And what we're effectively going to do is kind of waste map a site and try to look at that complete data of it to find where the materials are, who the people are. And that's our kind of first venture into doing something at that scale. So it will almost be an overwhelming amount of data maybe that we collect. So yeah, I think I've summarised those as the 2.5, I guess, main challenges.
Great, thank you both. That's really helpful. If you'd like to ask Tamsin and Grant any more questions, feel free to pop them in the chat, and we can come to those at the end. Thank you both for that. That's really insightful, really interesting, and great to see the real world examples too. I'm next going to go to Jason Cram, Technology and Innovation Director at WGM, who's going to talk through their work and also some real life case studies as well. Jason, over to you.
Thanks, Martin. Good afternoon, everybody. Thank you for joining us this afternoon. I am Jason Cram, the Technology and Innovation Director for WGM Engineering. I'd like to talk to you, following on from what Grant and Tamsin were talking about. I'd like to talk to you about some of the opportunities that mentioned by Grant and how WGM Engineering have turned these into real life examples of what can be achieved through a circular economy approach. So, first of all, I would like to set out what WGM's vision is. This was drafted up recently as part of our revised net zero route map, and as it says there, to be a net zero business and take every possible measure to accelerate our progress towards achieving this ambition and increase climate resilience by embracing circular economy principles. Now, this is something in my role that I've been very close to in the last few years, circular economy, and particularly waste reduction as well, and how they are very intrinsically linked, as I'm going to talk about on this next slide. So a report was done just recently this year by the Scottish Government, and one of the outputs from the report, as it says there in the box, recent research emphasises that most carbon emissions are embedded in the production of new goods themselves, therefore reducing the consumption of new goods and increasing the reuse of existing goods represents the biggest opportunity for mitigating carbon emissions. That's quite a long fancy way of saying stop buying new stuff and let's start to reuse the stuff we've got. And that's key to achieving the carbon reduction targets that the UK government have set. In order to do that, we really need to rethink our approach to investment, asset investment, and we need to consider the waste and therefore carbon impact our investment decisions have. All too often we jump to a default position of replace, and this is where we need to start changing it. We need to start thinking about refurbishment or remanufacture as a default position. It really is it's a sea change. We really do need to change the mindset, as I've said down there, to embrace the circular economy and realise the benefits we can get from remanufacturing. There are many different ways to look at this. In years gone by, I'm sure many of us on the call have grandparents who would roll out the phrase "make, do and mend." We've changed very much to a throwaway economy now, and we need to start go back and look at what we used to do. So again, circular economy, I'll skip this because most people know what it is, but traditional linear economy, as we've heard today, make, use, dispose. I think Martin called it take, make, dispose model, very, very similar, where new products are manufactured from new resources, used for the purpose they were designed, and then just disposed of as waste. Whereas in a circular economy, the materials are kept to extract the maximum value from them. And you can see in the circular boxes there in the blue, we've got make and use, which is the same as the traditional economy, but we've also got reuse, rethink, redesign, recycle. That's where the circular economy comes in, and that's what I want to focus on, certainly what I've been focusing on in the last few years, and hopefully we can get a lot more people to pick up on this. So in terms of the water industry, if you think about the equipment that's typically replaced, and the list down there, bridge scrapers, tanks, screens, etc., we pose the question, do you need to replace? Have you thought about remanufacture? And it's a question that was met with various different responses, to the point where we thought we're going to do some analysis and just figure out what the answer to some of those questions might be. And so I appreciate this is a very busy slide. I won't go through it all, but we looked at the 8 most commonly replaced assets within the water industry. So, MCCs, generators, pipework, screens, pumps, various sizes, valves, bridge scrapers, tanks. And we did an evaluation from a carbon point of view to see how much carbon emission would be emitted through remanufacture versus replacement. And the numbers are compelling, and not only from a carbon point of view. What we found was that with each of these examples, there was a significant carbon reduction through remanufacture rather than replace, but consequently there was also a significant cost saving and program saving that we weren't expecting, but it's all good news. And in some respects, it flies in the face of the opinion that's held by some people that climate change action costs an awful lot of money. I appreciate certain things might cost money, so renewables, electric vehicle charging infrastructure will cost money, but adopting the circular approach where remanufacture is at the forefront, there's a significant cost saving in the region of 50% in many cases. So we took this analysis, and again, working with Scottish Water, we looked at their investment period just now for SR21 and looked at the numbers of equipment that were forecast to be replaced, as you can see in the boxes there on the right-hand side. And we put the analysis in terms of cost saving and carbon saving across that whole programme. As you can see from the kind of lower right grey box, replacement cost of £11 million for the equipment, but crucially, 1,646 tonnes of carbon equivalent. However, if we take a remanufacture approach, it costs less than half of that and significantly reduces the carbon down to 355 tonnes. So overall, in the blue box, 54% reduction in investment costs, 78% reduction in carbon emissions. Those numbers are very, very compelling, and ones that can't be ignored. And this is where we then decided to try and not just talk about these on paper, but actually go and deliver some real world examples. So the 3 boxes in blue there, bridge scrapers, tanks and screens. I'm going to go on and talk a little bit about them in more depth and give you some examples we've already delivered. So this is the first one here. Grant mentioned it just recently about bridge scrapers and the partner ecosystem we're working on. So this was at Kilmarnock Wastewater Treatment Works, where we had 4 large bridge scrapers, as you can see the picture there. They were destined for replacement. So what you see there was going to get thrown in the bin or scrapped. And in actual fact, we looked at it and said, well, how much of that structure has actually failed or is at the end of its life? And 12.5 tons of steel in each bridge. We reckon we've managed to save 10 of that 12 tons in each bridge. So 40 tons of steel was reused. And the remanufacture of these bridges, we upgraded them, we made them more functional, greater operability, and really brought them up to a modern day standard, but not having to replace the whole bridge. Largely the superstructure was untouched. It was sandblasted, it was tested, it was checked, and brought back to life with a new coating to give it a 25-year lifespan. And as you can see, the numbers there through, the replacement was going to be 86 tons of carbon. Our refurbishment and remanufacture was 15 tons of carbon. So overall, a 51% cost saving, 50% program saving, and we avoided 40 tons of waste material, particularly steel. So when you're getting figures like that of 80% carbon reduction as well as the cost and program savings, these are very, very compelling. Second example would be glass line steel tanks. We've seen them all up and down the country in wastewater treatment works and water treatment works. Typically, the picture on the far left, you can see where at the water line they tend to corrode from the inside out. This is where that tank would then be deemed out of service and needing replaced. However, through our cold plate bonding process, we can bring these tanks back to life and give them back a 10 or 15-year lifespan, depending on the internal coating spec. And again, not having to replace these at Stirling Wastewater Treatment Works, massive savings in terms of 84% carbon saving and also significant cost saving because we did not need to replace the raw materials. It was only the patch repairs, so 87% cost saving. And again, we cut the time down by more than a third and avoided 10 tons of waste material. So again, very compelling numbers and a great way to bring otherwise assets deemed inoperational back into service. The alternative to these tanks at that time was tankering. The tankering costs were phenomenal to take the sludge off site. That's now significantly reduced as well, so a good news story all round. A third example we have here, these are storm screens, very, very common piece of equipment across water utilities up and down the land again. Inlet screens, storm screens, they do get a hard life. They do get battered by a lot of debris at times and can often fail. These particular screens at Shieldhall Wastewater Treatment Works, one of the largest in Scotland, were only 10 years old but had failed. And again, the asset owner had decided that the description of need was to replace 6 screens. And really, when you think about it and we looked at it, what are we replacing, or why are we replacing, should I say? It's more along, it's to replace the parts that had failed. But when you dig down into the screen and look at the parts that failed, they make up 10–15% of the overall structure. So the replacement would be to take those 6 screens out and all the steel and stainless steel that goes with them, and it's about 8 tons of steel in each one, and replace it with 8 tons of steel in a new one, plus some refurbished components, some new components. It just seems a false economy to throw away all that steel. There's nothing wrong with the structure. It's internal components. So we took them out back to off-site facilities, stripped them, looked at the problem and resolved the problem, which was a lack of wash water. So we doubled the wash water on them, remanufactured them to a certain extent from the wash water system point of view, and reinstalled them. And I'm pleased to say they're now working. And again, 77% carbon reduction, 56% cost saving, and we halved the programme, as well as avoiding the need for about 30 tons of waste material in the form of steel and stainless steel. So that's hopefully given you a bit of a kind of insight into the real world examples that we can and have delivered through a circular economy approach. And really what I want to do here is talk about end of life, and perhaps I think we need to redefine what end of life really means. You see a pile of scrap material there on the well, 2 piles of scrap material. one on the left is a kind of generic picture you would see in a scrapyard that's destined to be melted down and reintroduced to the supply chain with the production of virgin steel. On the right-hand side there, this was a dismantled structure that we were asked to remove and replace, and typically the steel work was destined for the scrapyard because it was deemed to be end of life. We challenged that, and yeah, it might have been end of life as that structural framework. However, as you can see from this slide, these have been remanufactured and tested and certified fabrication trestles. So again, there was no need for them to go to scrap. We've repurposed them into something very, very useful, and we've avoided all the virgin steel that we would have needed to use to manufacture these from new, and obviously the carbon emissions associated with them. So that is really redefining end of life. And again, when these become end of life, that doesn't necessarily mean to say they have to go and be scrapped and melted down. They can be used for any number of items, pipe supports, for instance, that are maybe not structural. You know, so that there's a number of lives. It's not just end of life once. Again, very typical in the water industry. A couple of examples of pumps destined for the scrap heap. Well, pump on the left was on the scrap heap. It's a water pump, and on the right-hand side is the wastewater submersible pump. Again, looking at them from the outside, you think, yeah, they need replaced. They're not salvageable. The reality is very, very different though when you've got, you know, workshop facilities that can look at these, and the result being, you know, the water pump you saw there. This was 5 weeks ago in our workshops, where the pump had been stripped, internals taken out to be remanufactured in our workshop. The internal casing and external casing coated with a high efficiency coating, and pump brought back into service. This is very much along the lines of what Grant was talking about earlier with the surplus assets. So these pumps will be remanufactured and put back on the shelf, ready to be used again at another asset, where we would hope to swap out one of these pumps with another one that had failed and do exactly the same process over and over again. And you can see on the right-hand side here, that is the other submersible pump, which has been refurbished, fully coated inside and outside, ready for the rotating elements to be put back in. So hopefully that's given you some examples of what can be done, what we are doing, and really redefining end of life, avoiding waste, and reducing carbon all at the same time. And really, you know, this is where we need to be going, and having this kind of circular economy approach to asset investment. So yeah, hopefully that's been insightful, and I'll hand back to Martin.
Great, thank you, Jason. Again, really useful to see some real life examples. One thing you touched on there was about changing the mindset. In your view, whose mindset needs changing? And given that the evidence you highlighted from the Scottish Government, and also in the case studies, what's the, not so much why is it so hard, but who do you start with? Whose mindset needs to shift in this debate?
It's a good question, Martin. I think there's a number of people, you know, top to bottom within the industry whose mindset needs to change. I think slowly, you know, the government are setting net zero targets, and you see some reports that I mentioned there. So, you know, at a government level, there's certainly the mindset seems to be, yes, we need to change. What I find though, that, you know, you come down to asset owners and operators, and they very much are the challenge at the moment. I suppose a simple example is, you know, I want a shiny new one. Why would I take a remanufactured, almost second-hand one? And I think it's really those embedded behaviours that the default is always replace. When something's failed, it will replace. We need to change that. And so these people, finding a way for them to think that, you know, not believe that they're getting something that's substandard, which is all about us making sure that we do a good job of remanufacture, repurposing, improving where we can, and supporting them such that the risk that they perceive has gone. So once we get these people then, you know, understanding that, you know, they're actually not getting something substandard. I mean, I compare this to the water industry, where you get, you know, the second-hand car, the car industry, vehicle industry. There's a thriving second-hand car market. I'd love to think that we had a thriving second-hand water utility equipment market, so to speak, where people believed that they could get a used approved piece of equipment. So it's at that level. Asset owners the default position needs to be refurbish or remanufacture rather than replace.
And how do you think we can best change the mindset?
Well, yeah, $1 million question. I think doing things like this, some of the examples that we've done working collaboratively with Scottish Water, we have got real life examples. These are not just examples on paper. They are live, and we've demonstrated through calculation and then through delivery the carbon reduction and cost and programme savings are real and tangible and very, very compelling. So we need to do more of that. We need to get more people to adopt this approach and show the art of the possible, so to speak. And I think one of the things we could do is incentivise refurbishment and remanufacture through supply chain, like engineering companies like ourselves, where Scottish Water have incentivised carbon reductions. That they're willing to pay a little bit more, even if something was more expensive to get a reduced carbon. That they're willing to do that, so they've incentivised that. And I think taking that further out into the supply chain to incentivise them, where again I talk about the automotive industry. Why can't we get a used approved pump? Why can't the supply chain offer a refurbishment of a screen rather than it's our default? We'll sell you a brand new one. So I think getting into the original equipment manufacturers and getting them to offer a refurbishment scope as well as a new equipment, I think that's the way to go. We talk about everything nowadays pre-loved. I'd like to see the day we get a pre-loved pump that we can buy.
Great, pre-loved pumps. Thanks, Jason. That's great. We just got one quick section, and then we'll head on to questions from attendees. I mentioned at the start in my introduction that we at Copper carry out public attitudes to infrastructure. We do that to understand how we can understand what the public thinks. We can make sure that messages resonate, but also give some knowledge back to the industry. And recently we've looked at water, so I just wanted to cover some of that today, particularly in the context of climate change, the circular economy, and what that looks like in terms of the challenges we face. So there's a report we've drafted, which we'll stick a link into the chat so you can have a look at it rather than me go through every single line in the report. But essentially, we surveyed over 1,000 people, which kind of gives you a representative sample of the UK. So if you scale it up, it's roughly what the UK looks like. And when we looked at water, what we found is that half the people feel, half people do not feel knowledgeable and half do. But what we found from diving a bit deeper is that almost 90% of people want to know more about water, that there isn't, and the environment as well, that there isn't a kind of lack of interest. So what does it mean for the circular economy? We've looked at what matters most at the next election. What we found is that the environment is really important in isolation. So when you ask people, is the environment important? They say yes, very much so. When you ask people to compare the environment against other issues, it drops quite significantly against the NHS, education, the economy, inflation, inequality, housing, trade with the EU, defence, faith and politics. Then you get to the environment. The reason for that, we think, is that the tough economy means that people prioritise issues that matter to them now, that affect them now, not things that may deliver benefit in the future. So it makes it harder to get cut through on subjects like this. Specifically, we tested water reuse with the public as well. And you'll see some information in the report. And there are a number of avenues open to water companies to build resilience and capacity within the networks, such as water recycling. And although the technology has been around for a long time, and we know it's tried and tested in the US and Singapore, it's not yet tested in the UK. And while people think it makes sense, they do want reassurance around the technology, the biggest concern being maintaining high quality drinking water. We found that the majority, 60%, feel that it makes sense, but they just need that, and about 25% need a bit more reassurance of that 60%. And less than 25% said they're concerned by it, and 5% said they don't care. So again, there is interest, and there isn't widespread opposition. So there appears to be a strong baseline of support for water reuse, but it can't be relied on because apathy can quickly turn into opposition, dominated by those most concerned. And the benefits of a whole life water cycle, keeping the water in the system, need to be really carefully communicated, because those that are opposed would more likely make much more impact on public opinion than a proponent of it who isn't cutting through. So there's a few takeaways we found around water reuse. One, don't mistake apathy for support. So vacuums usually turn into negativity. Two, converting reassurance into readiness. So clear, concise communications, keeping people informed, taking them with you on that journey is critical. Three, not one story is going to work. So you need to focus on demographics and understand how audiences consume information and what they want back from it. Four, the public needs to be educated. There's clearly an appetite for water reuse, but the story won't tell itself. And we've got to make sure that we keep people reassured and reminded about what the truth is, because there will be an awful lot of myths out there once this becomes more commonplace. Five, trust is absolutely critical. So empathetic, reliable communication shows dependability. And that gives you at least the starting point to have an honest conversation, to be able to build trust. Without that, what you can't do is just turn up late to the conversation and say, we have an idea. And then lastly, something I wanted to mention is that we're working with the Future Water Association, and we've started a group called the Reputation Steering Group, which is looking at all aspects of the water industry to help provide guidance and insight around how we can develop the reputation of the industry, because as you've seen today, there's so much good work happening. It's just not enough of it is talked about, and it's dominated by the wrong things. And the circular economy is a key part of that. So if you're interested in finding out any more, then do let me know. I'm going to head over to some questions now we have from panelists. If you'd all mind putting your cameras back on, then I'll make a start. So a question for Tamsin. Could the circular economy training be shared with Scottish Water supply chain and delivery partner organisations?
I'll maybe take that one for you, Tamsin. Sorry.
I was just going to say yes, but you elaborate.
Yes, yeah, I'd be happy to discuss that with anyone who's interested. So we had the circular economy at Scottish Water, which was on the deck. So if you email that, whoever it was that asked it, and we can definitely discuss that. The more people that do it, the bit of benefit. So yep, please email.
Question for you, Grant. How do you recover cellulose from wastewater?
Yep, I suppose without boring you to death of the full technology and how it works, effectively after that initial kind of screening stage, if you imagine a sieve that goes from bottom to top diagonally, and what we're doing is taking the product up, brushing it, water goes to the bottom, we're left with the kind of cellulose product at the top, and then we catch it. That's the simple explanation of it, without having to go into any detail.
It's a sieve. I mean, let's just say what it is.
It's a sieve. A sieve and some brushes and a belt. It's quite simple, actually.
And on that as well. So once you've got it, what do you do? How do you get it off site? How do you?
Yeah. So I suppose that's the parts that we're figuring out. So we need to figure out what we're doing with it exactly first. So we've got to determine, I guess, the material quality of it. It can be used in kind of planting, etc. So for us, we would rather use it. There's quite a lot of vertical farming initiatives around about Alloa, so it'd be a really good source there. So another nice story for the local community. It depends. Yeah, I don't want to say construction material. I feel like that's the answer for anything, but probably a better example is the kind of in farming.
Yeah, great. Sounds good. Jason, I believe this is a question for you. At which point can it be identified that replacement is needed instead of being able to refurbish? Thinking about any, and second part of that is thinking about any safety policy requirements too.
So identifying when an item needs to be replaced, it relies on, well, it's good old kind of planned maintenance, to be honest with you, looking after assets. But obviously, one of the things that Grant touched on earlier on, the importance of data. and condition monitoring, which is stuff we're looking at to keep an eye on our assets. You know, at the moment we have a lot of very old and aged assets, and in order to identify whether that is fit for refurbishment or not, we have to take it back to our off-site facilities. So taking the bridge scraper example, we took that back, we shot blast it, and we actually do a structural assessment, non-destructive testing on as much as we feel we need to. From visual inspection, we can determine where we need to do more intrusive testing. And once that's been signed off from a structural engineer, for instance, to say, yeah, it's still got its material thickness, it's good for another 10, 15, 20 years, we would then, you know, proceed with a remanufacture. However, if that came back to say, no, in actual fact, looking at the thickness and some NDT testing has said that the structure has failed or will fail, then we would also then go back and say, right, in this instance, it can't be. What we have done is there are certain sections of those bridges that were in a poor state, and we've actually replaced small sections of it, which again, through our workshops, we can do that. But really, it's about data, it's about looking after your assets and determining, you know, when something can't be replaced. And it goes back to this whole point about redefining end of life. If it has to be replaced, yeah, okay, we can replace it, but that doesn't necessarily mean to say that that then goes to the scrap heap. We're just replacing it as that item. It can then become something else. So it is very much, it's condition assessment. But basically, you look at, when people say thinking things be replaced, some of the examples I gave you, pump, for instance, the pump has failed, we need a new pump. Well, you don't need a new casing, you don't need a new volute necessarily, you don't need a new rotating element, you don't need new cables. It's the wearing components, seals, you know, wear rings, impellers, etc. That's the bits that wear. So you might have to replace the components, but you don't have to replace the whole pump. So it's about changing that mindset of that's failed, I need a new one, to that's failed, I need to see if I can make this or replace some of the components in it and put it back into service. I hope that's answered your question, I think.
Question for Tamsin: can we improve phosphates removal for reuse and reduce fossil fuel derived fertilizers being used?
Yes, we absolutely can, and I would say it's not only can we improve it, we need to. Phosphorus is a limited resource that we use every day, and we really have to get in gear and remove as much of it from our waste as we can. There is a really big challenge. So the technologies out there, Grant talked about the microalgae, which is one way we're looking at doing it, and that's because the microalgae captures the phosphorus in a way that it's easy to reuse. And this is the big challenge. It's about getting the resource out in a way that industry can use it really easily. So that's one part of the problem. The other part is around markets. So at the moment, recovered phosphorus or any recovered material really costs a lot more than the virgin alternative. So it's a bit of a hard sell to say to a business, please use our recycled material instead of this other one that costs a lot more, and then products go up and cost of living crisis. So this is a challenge. So I do firmly believe that if we're really going to start using recovered and recycled products, there has to be some regulation about the amount of recycled and recovered material that we use. So for example, fertilizers, we could move to a place where they need to have a certain percentage of recovered phosphorus in them, and then suddenly that opens up the market. Because we talk about the circular economy and everyone forgets about the economy part. We're very good at remembering the circular part, but it actually has to stack up financially as well. So absolutely, and there's lots of projects that we're doing around phosphorus in the water industry. Happy to talk about those all day, but we don't have time today.
Great, thank you. And then final question, given the time for you, Tamsin. Could you talk about how you and your team developed the principles, and then how you also got buy-in and alignment within Scottish Water?
Yeah, absolutely. So I'd love to say that Grant and I came up with them out of our own minds, but that would be a lie. So in true circular economy fashion, we actually recycled the ones from Ellen MacArthur. So if you're aware, the circular economy principles are eliminate waste and pollution, circulate products and materials, and regenerate nature. So those three were our starting point. And what we wanted to do was translate them into how can I statements for Scottish Water staff. So they really live. So it's like, how can I view waste as an opportunity? How can I keep assets performing? So really they could live and breathe. So once we'd kind of translated them into these statements, obviously talked internally, but then it was really important for us to take them to our kind of independent customer group, test them out with them, test them out with our communities to make sure they made sense, because we're doing everything in partnership with our customers. So if it doesn't make sense to our customers, it's not worth doing. So we tested it through that, and yes, they all made sense. I mean, there was a lot of wordplay, I'm not going to lie, but we got there in the end. And so really they're now kind of living, breathing statements in Scottish Water.
Excellent, thank you, Tamsin. And on that note, I'm afraid we haven't been able to answer all the questions that people have put through, but we will respond to them, and we'll make sure that the questions are circulated to all the panelists afterwards, and whoever has submitted a response, whoever has submitted a question will get a response. I'd just like to say thank you to everybody for joining today. I think the conversation was really interesting today, and that there were 4 takeaways that that I noticed from the conversation. One is the mindset shift and creating the change internally as well as externally is needed around the decisions we have to make and the changes we want to introduce. Which leads to the second point. It's not easy. Transformation is really hard because it involves taking people with you, and it involves a universal commitment to change, not just pockets. Thirdly is data. Grant talked about the need to have reliable data to be able to make decisions, and then to be able to embed that process of how data is used into your thinking. And lastly, I think Tamsin's point of how can I is an excellent way of ending today's session. How can I think is a brilliant way of, as you say, allowing these ideas to breathe and giving them life, and making sure that they become real, not just statements that sit on a shelf somewhere or sit on a website and are never seen again. I think that's a really good mantra. On that note, I'd like to say thank you to everyone for joining today as well. I hope you found the conversation interesting. I certainly have. It's been great to hear the real life examples, the principles, and Tamsin's approach of how you actually get from A to B as well. It's been brilliant too. So thank you all for joining. There's more Blue Thread webinars and podcasts coming up as well. So do keep an eye out on your various social channels to find out more. And we'll hopefully see you again. Thank you very much.
Thank you, everyone.